All right, 10.5 is the area of polar graphs. And there's a formula, of course, for area of polar graphs. And the area is equal to 1/2. That's important because a lot of students forget that 1/2, especially with the way that we do some of these. And it's an integral that goes from alpha to beta of r squared d theta. R squared is is the function, and alpha and beta are radial lines. Sometimes if you don't know what radial lines are, these are angles. Okay, these guys are angles. All right, so an example would be, if you'd like to see an example, here's three petal rows. So you know, hopefully you learned this and you looked at it, that it has to be 3 cosine of 3 theta. That has to be our formula, because we know if n is odd, it's that many number of petals. If n is even, then it's double the amount of petals. So this is what I'm looking at, this rows. Well, we have to first, before we could find the area, now once we find the area of 1 petal, we can multiply it by 3 to get the whole thing, okay? We can get half a petal, double it, and then multiply it by 3. So there's a lot of different ways to conquer this. But the biggest thing, or the first thing we need to do, is check out where those radial lines exist or where they are, okay? Because not all graphs have 2 pi as their period. Some graphs can have pi, some graphs can have pi over 2. So we have to kind of start graphing a petal to know what its period is. So let's get started. I have an example here. Find the area of the petal of a rose, and let's do that problem. Let's do 3 cosine 3 theta. Okay, so we know that that is a rose, all right? And, but wait, let's hold on. Let's find out, we have to make a little table here and find out what radial lines, what happens with the radial lines. Okay, so we get theta and r. Okay, those are our polar coordinates. So let's get some thetas. Now, how do we pick these thetas? Well, we find out when the cosine, okay, is maybe 0, all right? Or when this guy, when this is maybe 2 pi, I usually say 2 pi equals this thing, 3 theta. And now you can divide by 3 if you want, all right? Or pi equals that, and you divide by 3. So there are some of the ways we can conquer this. So I'm going to try 0, pi over 6, and pi over 3. Because that makes sense. 0, I always try 0. And basically what I'm looking to do, okay, my goal here is I'm looking to see what makes either half or the whole petal. That's my goal. From where to where? Because that's going to be our radial lines, and that's going to be our limits of integration. So that's really the challenge here, the calculus challenge. All right? So let's plug it in. When we plug 0 in for theta, cosine of 0 is 1. 1 times 3 is 3. So I know when I go to graph this, 0, 3, it starts here. Now, when I plug in pi over 6, let's see what we get. When I plug in pi over 6, that'll make this pi over 2. Cosine of pi over 2 is 0. So what must have happened is that my radial line, let me draw one for you, okay, is now pi over 6. So that's right there. I drew a radial line of pi over 6. And what must have happened is that this guy came around like that and made half a petal. I'm pretty done. At that point, I can go as limits of integration if you'd like. All right? I can go from 0 to pi over 6. Because remember, we're going from 0 here, and this, as I said, was pi over 6. Not too shabby. All right? So that will be half a rose. Let's continue. Watch what happens. And this is what gets crazy with these polar coordinates. If I go pi over 3, I get cosine of pi, which is -1, times 3 is -3. Well, look what happens. Now, when I'm at pi over 3, this guy must have went -3. So it went all the way here like that. We don't want that. At this point, we're done. Okay? At that point, we're done, and we can start solving the equation. And the equation goes like this. And how many petals did it ask us for? 1 petal. It's important. It's important to find out what our problem is, because if it asks us for all the petals, then we have to multiply it by 3 at the end. So we want 1 petal. So our formula is, from the formula, it's 1/2. Now I'm going to go from 0 to pi over 6. And it's going to be r squared, which is 3 cosine 3 theta squared. But wait a minute. That's only half this petal. So I'm going to need to multiply that by 2. I hope you got that. That only made half that petal. So I'm going to need to multiply it by 2. All right? That'll get me the full petal. So now the calculus takes over. Okay? We have, you ready? Square root of 3, it's 9, bring it outside. So it's going to be 9. The 2 and the 1/2, they undo each other. So it's going to be 0 to pi over 6, and now it's going to be cosine squared of 3 theta. Okay? D theta. And now we need something, okay? This 3 theta stuff, I don't think we can do anything with it. I mean, so what's going to happen, I guess, is we need a trig identity. And here are 2 of them that are very, very prevalent in this chapter, or in these 2 sections. We have a trig identity, or a couple of them. Okay, the first trig identity is sine squared theta equals 1 minus 2, I'm sorry, not 2, it's cosine 2 theta. Cosine of 2 theta, all over 2. That's one of them. Another one is, hold on, another one is cosine squared of theta is equal to 1 plus cosine 2 theta over 2. So these guys are 2 trig identities that you need to check out and need to know for this section. It makes it much easier. All right? Well, in this case, if I set, when I go and try and do this, so I think, folks, this is the one we're looking at. We have cosine squared, and now we're looking at this one. By the way, if it was 3 theta, if I put a 3 here, the only thing that changes is it makes this boy 6. So I'm going to go ahead and apply that identity. So I'm going to get 9. I'll bring the 2 out. So I got 9/2. Pi over 6, or 0 to pi over 6. It's going to be 1 plus cosine of 6 theta. D theta. Hey, let's just keep in mind here, folks, we're integrating with respect to theta. Okay? Well, I'm going to have a u substitution at this point. I'm going to say u equals 6 theta. Therefore, du is 6 d thetas. Okay? So if I'm going to do this, all right, you know, I may do this. If u is 6 theta, you got to be careful, because when you go ahead and take the integral with 1 with respect to theta, you get a theta. Okay, that's like 1, you get x. But now we're doing it to theta. So we got to be careful here. I might want to break this up to 2 problems to make it a little easier for Anya. All right, I might. It could be. For your first time seeing it, I might do this. Okay, take that, and now I'm going to add 9/2 from 0 to pi over 6. And now, get out of there. Okay. Now, I need to do, now I'm looking at this problem right here. Cosine 6 theta d theta. All right. Now I have cosine of u, but wait a minute. I have to multiply this guy by 6, so I get my 6 d thetas, but now divide this by 6, so it's going to be 9 over 12. All right. So my first one is done. This one is going to be 9/2 theta, just good old theta, evaluated at pi over 6 and at 0. And that one's done. We'll do that in a second. But now this one, okay, this one is going to be 9 over 12. All right, I'll worry about that later. And remember, this is now cosine u. Well, the integral of cosine is sine. So we're going to get sine of 6 theta. I'll replace it back. And now I'll get it from pi over 6 to 0. So I do these problems and I'm done. Let's recap, because the hardest part is this transition. I don't think the rest is that bad. Remember, I split these up because you just got to be careful. I guess you could have left the 1 in and made it theta. It just makes me a little nervous. So now I have, I don't know what this becomes. Help me. 9 pi over 12. 9 pi over 12 is something like 3 pi over 4. Okay? And then when you put 0 in, it's nothing. So then it's plus. Let's do this one. Let's put pi over 6 in. The sine of pi is 0. So the first term is 0. And wait a minute. Isn't the sine of 0, 0? So voila. Usually happens like that too. Okay? Usually the meat or the answer, all right, and this is kind of squared units. Okay, just remember we've measured some squared units. Okay? And that's 1 pedal. So multiply that guy by 3, 9 pi over 4 is the whole graph. That's the square units of the whole graph. But right here, remember, 6 times pi over 6 is pi. Sine of pi is 0. 0 times anything is 0. And the sine of 0 is 0. And it usually works out like that. All right? And I broke it up. I don't usually break it up, but I did. It's the first time you're seeing it. So if you have any questions. Oh, I forget. You can't ask me questions. All right. One more. Let's do one more. Then I'll give you a couple to practice, maybe 3 to practice. All right? So here's another one. 4 sine of 2 theta. So there we go. We got to think about what the graph looks like. This is a rose. This guy's even. So we're going to have to say, well, it's probably going to look something like this. But it doesn't necessarily draw it the way I drew it. It can draw it in a lot of different ways. It can draw it like this. Okay? It can draw it, I mean, it could be traced a lot of different ways. So we have to try and find, maybe one of them. Okay? And it says find the area of 1 pedal. It's important to know that we don't need them all. So now I'm going to start with 0. And when the sine is 0, you get 0. Okay? So let's go back. Let's make this a blank graph, or a blank sketch, if you will. Okay? So we're starting here. So when theta is 0, r is 0. And let's go to, like, if we choose pi, let's set this guy equal to 2 pi, all right? That might be too much. I don't know, with the 4 here. So let's try to make it, let's try pi over 2. All right? So if I plug in pi over 2, all right, if I plug in pi over 2, watch what happens. So sine of pi is 0, and I get 0. So I don't know what happened. So I need something in between. I went from 0, and now a radial line of 0 looks kind of like this. All right, and a radial line of pi over 2 looks like that. And I have no clue what happened in between. So now we have to choose. Let's choose something in between that. All right, so let's go pi over 4. Maybe pi over 4 will give us something. All right, so now this table is not going to be in order, but at least it's trying to help me go through it. So here, let's go pi over 4 now. All right, pi over 4, this is sine of pi over 2, which is 1, and now I get 4. So at the radial line, pi over 4, which is right in the middle, okay, I get 1. So what must have happened, now I'm cooking with oil. So what must have happened is I went here to pi over 4, and then as it got closer to pi over 2, it came back. Makes a lot of sense. Makes tons of sense. So now I have my limits of integration. Now it's up to you. We want 1 pedal. I could either make a formula of this, 4 sine 2 theta. That's supposed to be a 2 theta. You'll excuse me. Squared. And now I can go from 0 to pi over 2 if I want. Or I can get rid of the one